Yes, friends, here is a question based on gravitation. Mass M, and M are placed on the vertices of equal triangle ABC. Mass 2M is placed at centroid G. So here you are asked what is the total force acting on mass 2M. Actually here one way it is simple problem. If in question of 1 mark you are asked this question, 1 mark question, so you have to write answer 0. Why? But if they ask that prove that it is 0, then other thing. This question may be asked in 2 ways. In 1 mark you directly can be asked how much force is on mass 2M placed at centroid. Or other way you can be asked to prove that mass on 2M is 0. So simply so you can understand that this distance GA equal to GB equal to GC 1 meter है. So force vector due to mass M each has same magnitude, and these forces are at 120 degree from each other. This is 120, 120, 120. If 3 vectors are there which are at 120 degree from each other, then we can add suppose it is one force 120 degree angle this and then this. So resultant becomes 0 by symmetry. But mathematically how to prove, that is also simple. Here I have written I cap, j cap are unit vectors along xy axis, just to tell you. Now I suppose that centroid or mass 2M is placed at origin. I suppose the at origin x and y axis are there. So I cap unit vector along axis positive and negative right to left. Similarly I cap, j cap here positive and downward negative. The old convention of sign convention of graphical. Now I write here force FAG, force on mass 2M due to mass at M square FAG is equal to G into M 2M into M upon 1 square. In J cap vector लिखा है यहाँ vector, तो J cap means vector direction force this way, force on mass 2M due to this. I mean, or you can write it as FAG. हमने कहा force on G due to A. और you can write G है, ज़्यादा बेटर होगा. Force on mass G है ना GA. It is 2gm square upon 1 j cap. Indicate 2gm square j cap. Now this force FGB. FGB can be resolved along this direction and this direction. If angle 60 degree in equal triangle, every angle 60 and half of that 30. So this will be 30 also. This will be 30 also. So F जो GA है, that will be sum of this and this. This. So we can write FGB to GM square upon 1 minus I cos 30, I cap cos 30 degree. I cap component of this along this plus two GM square minus I sin 30, J cap sin 30. component source will be, but this angle is there. This component F cos 30, this is F sin 30, F is this. Similarly, F GC equal to 2gm square into I cap cos 30 और माइनस, ये मान हम यहाँ ला सकते हैं 2gm स्क्वायर j sin 30 माइनस, तो वो माइनस में यहाँ लिखते हैं, तो चलो वैसे लिखता हूँ माइनस j sin 30. So total force on G, ये लिखे वेक्टर Fg, वेक्टर Fg equal to Fga plus Fgb plus Fgc is equal to 2gm square j cap plus 2gm square, I write minus here, into I cap cos 30 plus or I can take minus outside. Two gm square j cap sin 30 plus 2gm square I cap cos 30 प्लस क्या माइनस 2gm square j sin 30. Now when you add these two get cancelled, it is sin 31 by 2. Sin 31 by 2 into 2gm. So we get it as vector Fg is equal to 2gm square j cap minus gm square j cap minus gm square, and it comes 0. So we can prove this force on this mass is 0. Now they ask another question here. If another question is there, if at vertex A mass if be 2m instead of m, then what is there? So that I am writing directly Fg then equal to this into this. अब ये 2m है यहाँ पर, तो it is g4 पहला gm स्क्वायर j क्या वो तो 1 ही है, और यहाँ पर ये इसका ये कैंसिल हो जाएंगे, और ये दोनों ऐड होंगे, जे कंपोनेंट। वो कितना था हमारा जे कंपोनेंट निकाला हमने यहाँ पर, -2gm² sin 30 जे कैप और -2gm² sin 30 जे कैप। ये क्या कंपोनेंट फोर्स में कैंसिल, तो इट इज 4gm² जे कैप and it is 31/2 minus 2gm² जे कैप लेफ्ट, इनका सम। तो फोर्स ओनली 2gm² जे कैप means force will be toward this, other force get cancelled. So net force here will be 2gm² J cap. You will do this if you are asked to prove. Otherwise, using symmetry, you can say if masses are here m, then by symmetry the force on whatsoever in mass 2m, 3m, 4m is 0. Now similarly, there are some good points regarding gravitational force here. Now come to force due to spherical cell. This is very important to know. What is spherical cell? A hollow sphere having mass distribution uniformly on the surface. Here is the mass. And let this mass be m. So number one, if a body of mass m is placed outside, then how much force will act on mass m due to this, and what happens if the mass come inside? Try to understand this topic. We have spherical cell, खोखला है, mass cell कहाँ है किनारों पर, only mass is here, inside it is hollow. Then how much force will act? Actually we can calculate the force of mass and due by taking these small elements, segments. तो उनका जो यहाँ पर मान लो ये एलिमेंट है, इसका मास फोर्स ही होगा, इसका एक कंपोनेंट है किधर, तो कंपोनेंट which are perpendicular to the line joining the two, due to all elements will sum up 0, because as one is this, other is this way. And component along axis there will be same direction. And finally, the force on mass m placed outside the cell can be calculated. I should say here gravitational force. The gravitational force. Gravitational force on point mass m. Point mass m placed outside the cell can be calculated using Newton's law. by assuming that whole mass of cell is concentrated at its center। यानी कि अगर ये सेंटर है और ये डिस्टेंस यहाँ से यहाँ तक r है, this mass I am supposed to be here and that force will be dm upon r square। If any point mass is anywhere outside, then we can think that as if the whole mass of cell is placed at center. But if this is very important to understand, we can do it by integration, but at this level integration application is not, we can use directly. We can think that whole mass of the cell is at its center. Now if find P inside, if point mass is inside the cell, anywhere, inside the cell anywhere, not only a center, यहाँ हो, then gravitational force due to mass of cell is 0, because again we can use है ना, ये एलिमेंट लिया, इसका निकाला, तो इसका इधर इनका निकाला, उनके कंपोनेंट सब add up get 0। So you can remember here, you can directly ask if this point mass and place, तो दे देगा कि 4 सेंटीमीटर है, 2 सेंटीमीटर है, कुछ भी दे देगा, but force is 0। So please take note this. I did this question for you, especially because generally it remains unnoticed. This fact at this level of class 11 level remain unnoticed. So I told you it here.